would you put a boat on a massive train and go over a road? This is the Big Chute Marine Railway. This strange steel colossus lifts boats out of the water up about 60 feet in the air and moves them across land on tracks. There is nothing else like this giant machine anywhere. Today, over 100 boats will make the trip. But just how does a century-old operation like this get that done? And why is it doing it?
I just got a text saying lots leaking from the carriage.
And really, if no one else is doing anything quite like this, why are Canadians moving boats with this huge contraption on rails? And what does this have to do with it?
Low. Here we go.
Cory runs the Big Chute operation in the Muskoka region of Ontario, Canada, and he's got the right title for it.
You have to know every aspect here to all the inner workings of everything to be called a lockmaster. Your head is constantly rotating to ensure the safety of all passengers, as well as my staff. There's so many risks on that carriage. Your whole team has to be on their A game.
This strange giant machine was built about 50 years ago to solve economic and environmental problems, and wound up having a bigger impact than anyone could have expected. Most locks raise or lower water levels to move boats, but Big Chute is what's called a patent slip. It has an open rail carriage that moves boats a distance of about 300 meters.
It takes anywhere from 6 to 8 minutes to actually take the ride over the Big Chute. Where the time changes is the loading and unloading of the vessels.
Run by Canada's National Park Service, Big Chute is popular among those using the Trent-Severn Waterway, a 240-mile-long stretch of rivers and lakes that includes more than 40 boat transfers, including the Peterborough Boat Lift. Depending on where you start, Big Chute is either the second or second to last one on the trip.
We can do 150 to over 200 vessels in a day, which makes us one of the busiest locks on the waterway.
He gets up at around 4 a.m. every day and gets to the site an hour or so before his shift begins. But today, Cory's team discovered a problem with speed. They're running slower, which could make it harder to get boats across.
I'm not sure where we go from here, because to be down that many feet per minute, we lose out on probably 4 or 5 trips a day. Currently having an issue with one of the air filters on one of the pumps for the drives, which is preventing us from being able to run at full speed.
Cory and his team have a bit of an added challenge to get the job done on a busy day like today.
Water crash guys, come right up to the front right.
The cost of riding usually depends on the length of your vessel, $1.25 Canadian per foot. This past summer, though, access to national parks was free. That might explain this busy morning. A few dozen boats are already lined up on either end. Today, the wait could be as long as 6 hours. The Marine Railway was originally built as a temporary solution for lumber and commercial routes. But over 100 years later, it's gotten busier. So if this old behemoth is supposed to carry all these boats over land, across a roadway, on rails, how does it do it? This steel framework stretches 100 feet across, riding on wheeled legs that follow dual railway tracks. It can haul boats up to 100 feet long, weighing 90 metric tons. A boat captain drives their vessel onto the open-ended carriage platform that starts submerged. Operators can control the lift from this pulpit and on the carriage itself. They use adjustable, hydraulic-powered straps to make sure the hull stays upright and secure, and 4 200-horsepower electric motors to actually move the carriage. On the dual tracks, the carriage's front wheels start higher, back wheels lower, automatically leveling the boat as it climbs the changing slope. As the carriage passes key points along the track, the 4-cable system automatically reconfigures, switching from pulling in 2 directions to pulling from 1 direction. 4 mine hoist drums control the show. 2 east, 2 west. They don't just pull, they brake and generate power, working together like a choreographed dance. The journey involves a 20% incline, a short trip across level ground, then down a 20% slope back to the water. Throughout this climb, the carriage stays nearly perfectly level. Only at the very end does it tilt slightly, nose down, to slip back into the water. An intricate system of brakes is used to reduce whiplash as it slows down. On a normal day, the whole contraption moves about 4 feet per second, or just under 3 miles per hour. But remember, they're running slower today.
I just got a text saying lots leaking from the carriage.
That's another problem. That could mean they have to halt operations altogether.
With us going in and out of the water upwards of 40 to 50 times a day, you can imagine the toll that it takes on a machine, especially of that size. Today we are having an issue where we're having a little bit of a hydraulic leak.
The team acts fast to try and fix the leak.
I have a background in line mechanics as well as tech support, which really helps me in my role as there is a lot of troubleshooting requirements to get us through day to day.
So if there are other ways of moving boats, why are they doing this? Why did they build this in the first place? The patent slip was invented in 1818 by a Scottish shipbuilder named Thomas Morton. Morton's idea to drag ships right out of the water cost 1/10 of the expense compared to other methods. Meanwhile, the Canadian government began investing in slips, locks, and canals to move lumber more easily and develop the wilderness. The Big Chute Railway was planned in 1914 to be a traditional water lock, but those took a ton of resources that were in short supply as World War I unfolded. So, a marine railway was built instead in 1917.
It was more of a block and rope system where the operators there would hand crank in wedges underneath the vessel that would get them over. The old one also would only allow the captain aboard. No other people were allowed on your boat, as it was just unsafe to do so.
It was meant to be temporary, but a post-war recession led locals to rebuild the railway almost entirely in 1923. That structure still stands today. Boat traffic picked up over the 20th century, and officials considered building a traditional water-based lock at Big Chute, which might move traffic faster. They needed something newer, modern, so you'd think they'd go with a lock, something less weird. But no, cost still played a part, for sure. But by the 1960s, another reason to keep the marine railway had reared its ugly head.
For a century, lampreys bred undisturbed in the lakes. The lake fish, trout, whitefish, and walleyes, had no defenses against these vampires of the sea.
The Atlantic sea lamprey was introduced to the Great Lakes via the Welland Canal in 1829 and had decimated a local trout fishery by the 1930s. The marine railway became a biological barrier. Suckers would fall off as the boat traveled over land, preventing further lamprey spread. So instead of a regular lock, the Canadian government commissioned a larger railway right next to the old one. Construction started in 1976, and it opened 2 years later.
The real advancement of the new carriage is not only the double tracks that allow the carriage to stay mostly parallel or flat, it's the hydraulic system that allows us to pinch or grab the vessels rather than the wedges or blocks that they used on the older version.
The railway solved multiple problems, keeping invasive species out and providing a cheaper way to move boats. But it did more than anyone expected. It became a tourist attraction unto itself.
This wouldn't have brought as much tourism to the area if this was a traditional lock. Not too many places you can go to see such a large piece of machinery that allows you to get so close to it and see the inner workings of it. Truly makes it the beast that it is today. There are some days where there could be upwards of 1,000 land-based visitors that come to site and don't always have safety in mind. We've had it where cars stop right in the center of the tracks because they want to get a photo of their vehicle in front of the carriage. So having our head on a swivel here could mean the life and death of someone who's visiting here.
With more and more automation happening around the world, could this operation be replaced?
In regards to AI technology, I don't feel that that's the way that this should go, as I still do feel that the need for the operators to be able to understand and know the questions to ask the boaters to load the vessels safely.
There are a few similar lifts like Big Chute left operating around Europe. But boat lifts have gotten much more sophisticated and more commonplace. The world's largest is a part of the Three Gorges Dam on China's Yangtze River. Big Chute is definitely lower tech, but it is the only place in North America where boats still ride a train from the water over land to get from one place to another. It is wholly unique.
I come into work and I truly feel that I know this machine almost better than anyone.
So while the carriage is running a little slower today, all the boats make it through by the time the site closes at 6:30 p.m. Even as technology advances, Cory believes the human element here is irreplaceable.
Keeping that tradition of how the vessels are loaded and offloaded, I feel is a true value. I truly love the brain requirements that are needed in order to load and unload the vessels here. The constant thinking and working on my feet truly is what keeps me here.
What started as a temporary World War I solution has become something iconic.
It truly is an amazing piece of engineering marvel. That's the best words that I can use, as an engineering marvel.
Big Chute is a reminder that sometimes the best solution isn't the obvious one. This quirky piece of Canadian infrastructure proves that when you can't go through something and you can't go around it, maybe the answer is to lift it using a train.